In this video, I'm going to show you how to do the problems on the practice test number 2. So for the first two problems, you're graphing. The first thing you want to do is mark down your HK values. So for the first one, it's -4, 0, since that number is a 4. And then the domain would be x is not equal to -4, and that's a forward slash. And the range y is not equal to 0, because those are your asymptotes, the lines that you cannot cross. So if you draw those in, you can't cross that line and you can't cross this line. Next, you make your XY chart, since we need x and y to multiply to -7. So we do 1 times -7, 2 times -3.5, and 7 times -1. You could use 14 and 1/2, but it just doesn't fit most of the time. So you might be able to fit it here on this one, but that's about it. Then I'm going to reverse those numbers. So -1 times 7, -2 times 3.5, and -7 times 1. So 1, -7, 2, 1, 2, 3.5. If you want to do 3.5 and 2, you can also do that point. And then 7 and 1. Same thing on the other side. So -7 and 1. -2, 1, 2, 3.5. And then -1 and 7. And then you're just going to draw that in. Make sure you extend your graph. Again, if you're not sure how it turns, you can actually do 1, 2, 3.5, and then 2. There would be a point right there. Give you a better idea of what was going on. For the second one, your HK is 3 and 4. So the domain, x cannot equal 3, and the range, y cannot equal 4. So if I draw in the point 3, 4, or the lines 3 and 4, your HK, we have a 12, not your HK, excuse me, your A value. So I'm just going to do all the numbers that multiply to 12. 1 times 12, 2 times 6, 3 times 4, 4 times 3, 6 times 2, and 12 times 1. I know that's a lot of numbers, but it'll just give you a much better idea of what the graph looks like. So then I'm just going to make them all negative. Again, the two numbers have to multiply to 12. So I have 1 and 12. I don't have room for that one. So I have 2 and 1, 2, 3, 4, 5, 6. 3 and 1, 2, 3, 4. 4 and 1, 2, 3. 5, 6, and 2. And that's pretty much all that fits on that side. On this side, I can go back 12 and down 1, and then 6, 1, 2, 3, 4, 5, 6, 1, 2, 1, 2, 3, 1, 2, 3, 4, 3, 4, 1, 2, 3, 1, 2, 1, 2, 3, 4, 5, 6, and then 1, and then down 12. So again, plot those points, draw in a smooth, rounded curve. On this side, you can't really extend it very much. So those are the graphs. For number 3, you have to, well, in this case, there's no factoring, so we're just going to multiply this out by combining the same terms in the same places. So we have 4 times 18 and 9 times 32 for the numeric values. We have x to the 3rd and x to the 14th. That's x to the 17th. And on the bottom, x to the 3rd only. For the y, I have y to the 5th, y to the 3rd, so that's y to the 8th. Y to the 4th, and y, that's y to the 5th. And then for the z values at the top, I have z. And in the denominator, I have z squared. So I'm going to go ahead and do the variables first. So I have 1 more z in the denominator. I have 3 more y's in the numerator. I have 14 more x's in the numerator. And then for the numeric values, 9 goes into 18 twice. And 4 goes into 32 8 times. So I have 2 over 8, which reduces to 1/4. So I'm going to go ahead and put a 4 there. For the next one, it's division. So I'm going to go ahead and factor the first part. That's x minus 4 and x plus 1. I'm going to factor the denominator. That's x minus 6 and x plus 3. This has to be flipped. So when I flip that, you're going to get the x minus 6 at the top and the x plus 1 at the bottom. Once you've factored everything, go through and cancel anything that's alike. X minus 6, x minus 6, x plus 1, x plus 1. So your final answer is x minus 4 over x plus 3. For the next problem, it's also division, which means you also have to flip that as well. In the denominator, I believe that was a 12 there that maybe I erased. That is a 12. So in the denominator, that's x minus 3 and x minus 4. This gets flipped, so this goes at the bottom part, and you can factor out a 5x from that. And that leaves you with the 4x minus 1. The 15x squared goes at the top now. And then this one we have to factor. So you're looking for the factors of 16, they give you negative 8. Let's use the box method. So we're using negative 4, negative 4. And then the other numbers that we put in are the 16x squared and the 1. So that's 4x minus 1. And then this is a negative 1. So it's going to be 4x minus 1. 4x minus 1. So the 4x minus 1 cancels. The 5 and the 15 do reduce, so I can cancel the 5 and the 15 three times. I'm going to circle it to make sure that I still have it. And then the x and the x squared also reduce. So the x goes into x squared and you have x left. So at the top, I have 3x and 4x minus 1. And at the bottom, I have x minus 3 and x minus 4. Continuing on the practice quiz 2, going to problem number 6. We need to factor this. So we have x minus 3. This is a multiplication, so nothing needs to be flipped. The 2x minus 8, you can factor out a 2. The 6x squared minus 96, you're going to be able to factor out a 6. And then that's going to leave you with a minus 16. Or x squared minus 16, which can be factored into 6. And then x plus 4 and x minus 4. Okay, so you have to factor it in 2 steps. The x squared minus 9 is an x plus 3 and an x minus 3. Cancel like terms, so x minus 3, x minus 3, x minus 4, x minus 4. The 6 and the 2 will reduce. You can cancel the 2 and it goes into 6 3 times. So at the top I have a 3 and an x plus 4, and at the bottom I have an x plus 3. So 3 and an x plus 4, and then at the bottom I have x plus 3. To add and subtract, you need to find the least common denominator and then make all your denominators the same. So first thing you want to do is factor the denominators. The factoring part should be easy at this point for these kind. So my LCD is 6 times x plus 4 times x plus 5. So I need both denominators to look like this. So this one needs an x plus 5, and you need to multiply the top and bottom. This one needs just a 6, and again, you have to multiply top and bottom. Once your denominators are identical, then you can go ahead and just substitute LCD in their place for right now. So at the top, when I multiply this out, I'm going to get x squared plus 5x. And when I multiply this part out, I'm going to get plus 6x plus 12. I'm going to finish combining the stuff at the top. So x squared plus 11x plus 12 over the LCD. You can't factor the top, you 12 to get 11. They're both positive, so 1 times 12, that gives you 13. 2 times 6, that gives you 8. And 3 times 4 gives you 7. So nothing gives you 11. So your final answer is x squared plus 11x plus 12 over the LCD, which is 6 times x plus 4 times x plus 5. And you want to not multiply that out. You just leave it the way it is. For number 8, we need to transfer this minus sign. And I would also factor the denominator. X plus 4, x minus 3. So my LCD is x plus 4 and x minus 3. So this denominator already looks like what I need it to look like, so I don't need to add anything to that or multiply anything to that, For the second one, I do need to multiply this by an x minus 3 in the numerator and denominator. So now since the denominators are the same, I'm going to go ahead and write LCD. The first term is just 3x. And then the second one, we're going to distribute that minus 6. So I'm going to get negative 6x plus 18. So if I combine those, I'm going to have 3x minus, I'm going to have 3x minus 6x, which is negative 3x plus 18 over the LCD. You can factor out a negative 3. That leaves you with an x plus 6 over the LCD. The LCD is x plus 4, x minus 3, so nothing's going to cancel. So I have negative 3, x plus 6 over x plus 4 and x minus 3. Number 9, I'm going to go ahead and factor the denominator. This would give me x plus 8 and x minus 3. And again, I'm going to cross that off as soon as I find that. The LCD is x minus 3 and x plus 8. So I need to multiply this by x plus 8 for top and bottom. Now my denominators are identical. So if I multiply this out, I get 5x squared plus 40x. And then I have this part. So plus 4x minus 9. I'm going to combine all that. So I'm going to get 5x squared plus 44x minus 9 over the LCD. This will factor because I can tell that that's negative 45. And I need to get 44. So it's going to be negative 1 times 45. So using the box method, I have to use negative 1x, positive 45x from here. And then I have the 5x squared, and I have the minus 9 from there. So here I can just take out an x only, and leaves me with 5x minus 1, and then that's going to be a plus 9. Neither of those will cancel with the denominator, so I'm going to go ahead and write those in. 5x minus 1, x plus 9, and I'm going to put the LCD back in, x minus 3, and x plus 8. So this is this part, and the LCD comes from the LCD. For number 10, I need to factor this denominator, so x minus 5 and x plus 2. Cross that off. So the LCD is x minus 5 and x plus 2. If you're going to write the LCD, don't put it right next to it. That's kind of where you're going to do your work. So x minus 5 this means. So my denominators now look alike. I'm just going to go down here. So they both have an LCD. When you multiply by binomial, make sure you use parentheses, please. So that's going to give me 5x minus 25. And the second part, I have a 35. That's plus 35, which is 5x plus 10, which is 5 times x plus 2. And your denominators, those will cancel. And then you have x minus 5. These ones are the equations. So we're going to solve an equation. You're going to get an answer for x. So for a proportion, you can cross multiply. So it's going to give me 14 times 3x minus 7 is equal to 7 times x plus 1. That's 42x minus 98 is equal to 7x plus 7. I'm going to go ahead and subtract 7x and add 98. So on this side, I have 42x minus 7x, so that's 36x. On this side, those cancel, so I get 98 plus 7, which is what? Oh, this is 35, not 36. So that's 35x, and this is 105. So x is equal to 5. No. X is equal to 3. When you check your answers, it does not make that 0, and it does not make that 0 when you get x is equal to 3. So 3 is an okay answer. For number 12, your LCD is going to be 3 and x squared. So I'm going to multiply this by 3x squared. I'm going to go ahead and multiply the 3x squared like this. You can multiply it however you want. The reason I'm doing that is so I can just cancel out one at a time. So here I'm going to cancel out the 3. And I'm left with x times 1. For the second part, I'm going to cancel out one of the x's. So I'm left with 3 times x times 2. And for the last part, I'll cancel out the x squared. So I'm left with 3 times negative 3, which is negative 9. Remember, whatever's left over is all multiplied together, not added or subtracted. It's all multiplied together. So this is x squared plus 6x plus 9 equals 0. When you factor that, it would be x plus 3 twice. Again, don't forget you still have equals 0 the whole time. And then when you solve this, x is equal to negative 3 twice. It's a double root. It doesn't make any of the denominators 0, so you could just write x equals negative 3, double root. I probably wouldn't mark you off if you didn't put double root, but it is a double root. For number 13, you have the LCD, which is x and x plus 2. So you have to multiply everything by the LCD. Make that plus a negative. X and x plus 2. And here, same thing, x and x plus 2. After you multiply everything by all of the LCD, we're going to cancel denominators. There's no denominators here. So basically I have 2x and x plus 2. For the second part, the x plus 2 cancels. So I have minus 4x. And then for the last part, the x cancels, so you have 2 times x plus 2. If we work this out, I'm going to get 2x squared plus 4x minus 4x is equal to 2x plus 4. So now I have 2x squared. Those cancel each other out. 2x plus 4. So if I move everything to one side, I'm going to have 2x squared minus 2x minus 4 equals 0. Basically, I'm going to subtract this over to this side. And subtract that over to that side as well. So you're left with this. Divide out the 2. And then factor. So the factors of negative 2, they give you negative 1. When you solve this, you get x is equal to 2, x is equal to -1. 2 is fine because it doesn't make either one of those 0. That's 2 plus 2, and that's 2, and then -1 is also fine, so both answers are okay. For number 14, we need to factor this denominator into x plus 2, x minus 2. That's the LCD. So we're going to multiply everything by x plus 2, x minus 2. And you have to show that step even though I know some of it's going to cancel out. So if x minus 2 is gone, all of that is gone, x plus 2 is gone. So for the first one, we're left with a 4 and an x plus 2. The middle term, you're left with a 6x squared. And then this side, you're left with a 3x and an x minus 2. So we're going to distribute that. Combine like terms. Actually, I'm just going to rewrite this. So 6x squared plus 4x plus 8. 3x squared minus 6x. Then I'm going to subtract 3x squared and add 6x. So everything's on the same side. That gives me 3x squared plus 10x plus 8 equals 0. We're going to have to factor this. So the factors of 24, they give you 10, which are 6 times 4. So using the box method, which you have to use, 6x, 4x, 3x squared, and 8. So that gives you 3x. That's the greatest common factor between those. And then x times 4 gives you that. So that's 3x plus 4 and x plus 2. Set those equal to 0. 3x plus 4 equals 0. 3x equals -4. So x equals -4 thirds. And x equals -2, which we can't use because it makes that equal to 0, that equal to 0. So it makes your denominator equal to 0, so we don't get to use that one. It's called extraneous. For number 15, the LCD for number 15, you don't have to factor anything, is x and x plus 2. So x plus 2. Cancel out your denominators. So we're left with 5 and x plus 2. In the middle, you're left with x and x plus 1. And at the end, you're left with x and 2x plus 9. So 5x plus 10, x squared plus x, 2x squared plus 9x. So on this side, I have x squared plus 6x plus 10, 2x squared plus 9x. You want your x squared to be positive when you're about to factor, so I am going to move all of these things to this side. So all the stuff on the left, I'm moving it over to the right. So minus 6x and minus 10. And that means that on this side, on the left side I have 0 because I moved everything over. On this side I have x squared plus 3x minus 10, which is x plus 5, and x minus 2. So you get x equals -5, x equals 2. 2 is fine here, and -5 is fine. They both work. For the last two problems, we just need to write an equation and then solve the equation. So the first part is to just, says the number of hours needed to assemble a computer varies directly as the number of computers and inversely as the number of workers. Next thing we want to do is solve for A. So I just go ahead and put A in right away because I know that's what I'm solving for. 4 workers assemble 12 computers in 9 hours. Wrong place, sorry. Let me start over. 12 computers, the 12 goes here because that's where the C is, in 9 hours. Then I have 9 is equal to, this is 3A. So A is equal to 3, which means I'm going to plug that in there, and that's going to be your first answer. 3C over W. And then, so if I use H equals 3C over W, and how many workers? 48 can assemble 48 computers in 8 hours. So I'm going to multiply both sides by W. That's how you can get the W out of the denominator. So 8W equals 3 times 48, which is 144. And if you divide by 8, you get 18. That's W, so it should tell you that it's not hours, it's 18 workers. And then for the last one, we received $55.35 in interest on the $1,230 in our credit union account. So there's no formula there yet. And the second one says interest varies directly with the amount deposited. So that's it. So then I'm going to go ahead and use the numbers at the very beginning, where it says that she earned $55.35 with $1,230 in her account. So if I divide that, 55.35 divided by 12.30, then that means she's making 0.045, which is about it's exactly 4.5%. So I'm going to plug that number in here. So that's going to be my equation. I is equal to 0.045 times the number deposited, so interest, is equal to basically 44.5%. And the last part says the interest, how much would she earn if she deposited $2,000? And so you multiply that times 2,000, and she would earn $90 for interest. And that's it. That's the end of the practice test.